This is the Amp Hour Podcast. Released November 15th, 2020. Episode 517. Depth in AI with Brandon Gilles and Brian Weinstein. Welcome to the Amp Hour. I'm Chris Gamble of Contextual Electronics.
Hi, I'm Brandon Gilles of Luxonis Holding Corporation.
Hi, I'm Brian Weinstein of Luxonis Holding Corporation as well.
Hey guys, how you doing?
Great.
Yeah, doing well, thanks.
We are not coming to you live with video, but it seems like that would be maybe a better thing to do because you guys make AI-based video solutions, or maybe video-based AI solutions that work with Opencv. And so can you tell us a little bit about what you're building there and what your project entails?
Yeah, so the product is effectively a system that allows you to embed human-like perception into like an actual embedded device. So not like a whole computer, but it's true embedded. So you can have like an SPI output to, an at Mega if you want, or to an ESP32. So it does that leveraging the Intel Movidius Myriad X, which is this performant computer vision spatial AI and computer vision chip. And so you can do things like, perceive a water bottle and get its XYZ coordinates in meters, and then just get that as metadata out to some, motor controller, driver, microcontroller to have a robot know where that thing is and track it in true embedded solutions.
And so if I go and buy one of these boards, so it's called Depth AI. And if I go and buy one of these boards, I basically make like a plug-in to the carrier, and then it just kind of works. Is that the thinking?
Yeah. So there's a couple of options right now. So if you want to design your own hardware, we have open source Altium designs, and then a system on module with a 100-pin connector. And so you can design your own board, and then you can have a motor controller if you're building a robot on that board. We also have USB-based versions, so you could just buy our USB-based version, power it off of USB, and plug it into like a Raspberry Pi. So if you're already using that, you can do it. And then we also have variants that have, or a variant that has a built-in ESP32, which acts as our like embedded reference design. So in that case, if you're already doing ESP32 stuff, then you can just run your code on the ESP32. We already have a library to pull the data off, and then you can drive actuators directly or do whatever integration you're doing to like a smartphone or to a web app or something like that.
Yeah. And so what is the target? I mean, what's the target market for this sort of thing? I mean, who do you expect your customers are?
Largely, we just built it because we saw that
everyone and their grandmother.
Yeah. So it's this crazy new capability to have human level perception on an embedded system. And so we were trying to solve a like life safety problem. And that's how we ended up stumbling upon this. So like for a kind of sad period in my life, like everyone I knew was getting run over by distracted drivers. So like people who were texting or reading Instagram while they were riding their bicycles to and from work. I was almost hit, and then one guy who runs the hackerspace in Longmont actually was killed, and then one of my friends got a traumatic brain injury, and then one of my like dad's good friends got a broken back and shattered hip and broken femur and was like bedridden for 9 months. And all just distracted drivers like looking at their phone. There'd be like little fender benders if it was like car on car, but it's car on person.
Right. And Colorado has a higher biking population, but that shouldn't mean that there's driving with a distracted driving is better. That's worse.
So I'm like the stereotype. Yeah. So it causes a lot more carnage. And so I was already working in like embedded AI, embedded CV, actually for some like augmented reality stuff. And so I just like hard pivoted because I was like, well, this seems like a solvable problem to have computer vision and AI perceive the world to know a vehicle's on your trajectory. In all of these cases, like minute adjustments from the driver would have saved lives. Like the guy who died, he was hit in the back of the neck by the mirror. So like if the car was just like 4 inches to the left, it would have been fine. So I sought out to build a device that could be like a human riding on your bike, looking backwards, that could just like...
so it's for the bike too. Okay, I was thinking it's for the car, which would make sense because they're the idiot, but yeah, I see. So it's like a protective self-defense kind of mechanism.
A protective system that could perceive that the car is coming and then like take action. So there's this Kickstarter by Jonathan Lanzi in 2012, because I've been a bike commuter for a while, and so I saw that. I almost backed it, but I didn't quite have the money to do it. Didn't want to just back a random Kickstarter project, but I should have. And it proved out that if you put a car horn on a bicycle, you can prevent accidents if you know they're going to happen. But it turns out that only like 20% of the time do you, as the person riding the bike, know you're about to get run over because you're getting run over from behind. And so the idea was, why don't we just make this automatic and use computer vision to do it? So like if you're about to get run over, just honk at the car and swerve away. And Jonathan Landsey had already proved that's extremely effective. And then you could do other things like haptic feedback to the biker when someone's like on your trajectory further out. And also like audio alerts, and then flash LEDs that would otherwise be way too bright to like run all the time, right? So like you try to get attention by like help the person riding the bike to be aware that they're at risk, like a vehicle's on their trajectory at a distance or behaving erratic based on like what the AI model says. And then if all else fails and you have to take action, honk a car horn, which is proven to like give you that swerve. And that's all you need is like, in most cases, it's like 5 inches of swerving to the left and they save your life, sort of thing. So that was the idea. And
I feel like we should pause and say, and yeah, there's certain places that have this figured out. Like, all the people in Amsterdam listening right now are like, well, why don't you just fix it at a systemic level? And the answer is,
yeah,
it's getting better in the States. It's not there yet at all. So
yeah, I calculated the number of roads you'd have to redo in the United States, and I don't remember. It was like 300 million miles of road you'd have to redo.
Yeah, that's a lot of asphalt.
and don't get me wrong, that's where I want to get. But if people I stopped riding my bike on roads, and so did all of my friends.
Yeah.
Because of this.
Right.
So if people stop riding their bikes, where's the demand to cause the supply of roads that are better for people who ride bikes? So, and I'm a technologist. I'm really bad at anything that involves like marketing, for example, quite bad at, and that's evident in a lot of ways. But then also
you mean if you're going to go for like a policy-based solution instead of a technological
politicking and stuff.
Yeah. And that's a slow grind anyways, right? I mean, that just takes a long time and, not guaranteed.
Yeah, exactly. If I convinced everyone in the United States that this is the best idea and we should go after it, there's I don't actually know how many 300 million miles of road that need to be repaved. I'm not going to see that repaved in my lifetime, even if the full US went after it 100%, right? And being a technologist, I was like, I could probably do something. So I wanted to see, could you build a device that could reliably do this? And so I talked to a bunch of technologists. I got to talk to the CTO of Waymo at a conference ever so briefly, but cool. I got to ask him about it. And I got to talk to normal people and bike commuters and cyclists. And, all the computer vision experts were like, well, yeah, dummy. Of course you can do that. Autonomous driving. This is just the dumb version. Only challenge you might have is can you make it low power and then embedded enough to be like a bike light that you put on a seat post. And then everyone else that wasn't a computer vision expert, and I was kind of in the middle, were like, of course you can't do that. There's no way. You're talking about inches of detecting a near miss versus a glancing blow that could kill you. It can't perceive at that level. And so I built a prototype and I was kind of in between, there's these computer vision experts CTO of Waymo to just, someone who likes to ride bikes. And I was kind of in between, an engineer speeding up on computer vision, but not that far. So I wanted to prove it to myself. So Brian and I actually built a prototype using off-the-shelf components, a depth camera from Intel, D435, a neural compute stick, Raspberry Pi, a bunch of USB stuff to plug it all together, and it ran.
And then
super slow.
And then a car battery.
Yeah, it was a RC car battery actually.
Yeah. Okay.
And it literally chopped the connector off one of my RC cars. It was a 7,000 milliamp hour battery. And it's just, of course, will run forever at that point because those things are humongous. But we put it together. It ran at terrible frame rate, but even that, it was 3 frames a second. But even then, it could tell at 20 feet, a glancing blow versus a near miss within inches.
Wow.
And so it was very doable. And that's what all the computer vision people told me, but everyone else said it wasn't. And so it only took maybe a couple hours of coding, actually, once we figured out the neural architectures we were going to use and the components we were going to use. And it spent a bunch of time zip tying it together. And so we realized from that there's this the combination of depth perception when combined with artificial intelligence and performant CV is a cheat code for interacting with the world and perceiving the world.
Yeah. Yeah, because that's interesting. The CV piece, it feels like whenever I hear about Opencv and projects like this, it's more like, oh, well, we can tell if it's a dog or a cat, or we can tell
Yeah.
if it's a, like a bottle of champagne and all these different shape detections. That seems like a little bit less. I mean, that is useful, but I think more like that's on like a assembly line. It's like, oh, okay, well, we have, 14 pancakes coming down the assembly line right now. Let's pick them up with a
Yeah.
robot and tell where those are. And it's like that doesn't help me. Whereas this application feels very. I mean, obviously it's good story. I mean, it's well said, but it's like it feels more visceral. It feels like more real world kind of thing.
Yeah, and that was actually it. That was exactly it. I meant to say, like, you had these tools that gave you in pixel space information, but so you kind of get lulled into this sense, like, fantastic, that's all I need, right? Like, you can clearly see where it
Right.
is,
Yeah.
and then you try to go do something in the physical world. I'm an embedded systems engineer, so it's all about physical world and building things. And you're like, well, you can't. And then at least when we started, it's like a kludge of various things to then do that in the physical world and do that physical interaction, but you could do it. And Brian and I kludged it together as best we could. Then we wanted to actually productize, right? And we discovered that there was no way to actually just like embed this power. So you could use a depth camera with a computer with like a neural accelerator to perceive the world like this, but there was nothing that was just one chip that would allow you to do this, where there was a development platform available. And I guess to correct myself a little bit, the chip existed, but there was no
Right.
development
Right.
platform that allowed you to use it to do this sort of thing. So we had bought a depth
Yeah.
camera
So
and go ahead.
let's talk about what that chip is. What
Yep.
is this technology stack that's in here? Because I don't. You had said all these things. You said like a 435. I know what a Raspberry Pi was, but like, what are some of the tools of the trade that you went out and got in the prototype, and then how that translated into this embedded solution?
We were trying to do depth sensing, and one of the more popular depth cameras is Intel D435. They have a newer D455 now. So what that does is it's a two camera disparity depth assisted by like a stochastic pattern projector. So it's just like our eyes. So you use two cameras, and then the disparity in the two images is how you perceive depth. So we just do this intuitively. There's a neural network in our brains that do this. With, like, if you look at your finger in front of your eye, like, it's the difference between the left and the right image gives you the depth. And so depth cameras do the exact same thing. Are disparity-based depth cameras. It's literally finding some feature in the left image, finding some feature in the right image, matching them, counting the number of pixels, and then the depth is inverse to that. So the closer it is, the wider there's going to be a
Ah.
disparity in pixels. The
Okay.
further away it is,
So you're saying like as someone has like a finger out at arm's length, and
yep,
they draw it towards their eye or towards the bridge of their nose.
yes,
The left eye sees maybe so if there's light on the left side of the finger and there's darkness on the right side of the finger, the left eye sees the lightness more at the far point. They see both, right? But as they get closer and closer, only the left eye can see the light side because it's on the left, and only the right eye could see the darkness because it's on the right. That kind of idea.
yeah, and there's a separation. So if you like look to infinity, effectively, that separation
Mm-hmm.
grows as your finger gets closer. And
Mm,
that's what
yeah.
these depth cameras do. That's what the D435 does. So then it produces this pixels-wise depth map of the world. So where every pixel, and I believe it's 1280 by 800 resolution, you get a depth for that pixel. So instead of like an RGB image or a grayscale image, you literally get a depth map, which is super
Oh.
useful. And you can do things like mapping rooms with it, or recreating 3D models of sculptures or computers or whatever you want. I believe a depth camera was actually used to cheat in Formula One to copy the exact like shape of one of the downforce elements. And so one team, I think, like copied Mercedes or something using the depth camera. So that's what
Mm.
these depth cameras have been used for, is generally mapping or simultaneous location and mapping. Like, okay, I'm somewhere. Let's figure out what's around me and where I am relative to just generally these nebulous blobs. So that's what we're using to give spatial information in the prototype. The reason those cameras have just been used for mapping in the past is you have to figure out, how do you make sense of this? You just get these points of depth, but you don't have any idea what it is. So if there's like a whole group of bikers or something, or if it's like a school bus versus a car, or versus like a wall, like, it's really hard to know algorithmically what it is. And that's where AI comes in, where it can super trivially know what those things are. So the AI part, we were using the Intel Neural Compute Stick, which was actually their Myriad 2, and then we also used the Myriad X, which exposes just the AI portions of that chip. So we were combining the depth from this Intel D435 depth camera with the AI from the neural compute stick, and we were doing all the combinations of that on a Raspberry Pi, which meant all the video and depth data and everything had to go through the Raspberry Pi, get processed, reformatted,
Glue it back
rescaled,
together, overlay
glue
it.
it together, over USB, and then send it out to the neural compute stick to make sense of what it is, to perform the artificial intelligence. And then we were doing action based on those results. So there's a car or an edge of the car at this distance, and figure out what the trajectory is, sort of thing.
Okay. And so if people go to luxonics.com/depth AI, you can see, I'm going to guess, Brian or Brandon dancing in front of a camera. It's great. There's like a video in the background, and it shows that there's a person and a chair. And that's so this is what people have seen before. Like, this is the image classification, right? It's a chair, it's a dog, it's a car, whatever. That's the AI piece. And then there's overlay of actual XYZ information. All right. It just got closer to the camera. I'm pretty sure this is Brandon now. So this is Brandon dancing in front of the camera. So if you want to see Brandon dancing, go to this. We'll have the link here.
Yeah.
It's pretty cool though. So like the depth information, it's like a point cloud, sort of. I mean, I don't quite. What is the actual? Is it like a matrix of something, or how does it actually get pieced together?
Yeah, so it can be projected into a point cloud, but the depth map itself is literally like a 2 byte. So it's a 16-bit integer. So every pixel just has a value that is literally how far away whatever it is in that location is.
So it's a 2D map, basically.
It's a 2D map, yeah. And so then you can take that depth, and if you know the intrinsics of the camera, like the field of view and in warping and so forth, and horizontal and vertical, then you can reproject that into every pixel, then having an XYZ, which is the point cloud you mentioned. And so we have examples to do that as well on Depth AI. But to back all the way up, this depth camera and then the AI processor are all smashed together. So the Myriad X actually has all of those in it. In fact, it has three. It has the capability to be 3 depth cameras, and it has 2 neural compute engines and all that. So it was funny to be using, when we built this prototype, neural compute stick 2, which has a Myriad X in it and can act as a depth camera and all these additional things to do only AI, and have to buy another depth camera. And the thing has a dual core CPU in it, and you have to buy a Raspberry Pi. We're like, well, this like literally it's already here, right? Like we have this huge kludge of stuff, but the chip that does all of it is just right there, and that could build the whole thing. And so there's a long explanation of why it hadn't been done yet, but we said, well, if we're to continue here, there's no other chip that can do this. We need to figure out how to build the platform that allows us to solve this problem.
Got it. Okay. And so you did that. I think that's the fast forward here.
Yep.
But let's talk about the actual SOM itself. So like, what is actually on the SOM outside of this? So it's got the VPU, which is the Myriad X chip, it seems like. What else is on there? And then like what could people expect to interface with it then?
So the main differentiation, there are Myriad X SOMs out there. So you can, of course, the neural compute stick 2 isn't a SOM. It's just a USB little like thumb drive looking thing. But there are PCIe SOMs that exist, but those are all still used like a neural compute stick 2. So you have to put it in a computer or with a computer that has PCIe. And we wanted to make this, we wanted to use the chip as it was originally intended, which is to connect it directly to cameras. So it has the capability to ingest MIPI data, so to connect directly to cameras. And so that's a lot of the reason for the SOM and then the interface we have. So it's a 100-pin interface that allows you to connect to global shutter, grayscale, and then if you choose, you could use other cameras. Our default is 2 global shutter grayscale for stereo depth, and then a 12 megapixel color camera. And we can probably jump to Brian to get into.
I was going to say before. Yeah, I'd love to hear from Brian too. We did learn about MIPI, and if so, from 2 episodes ago when we had Jay Carlson on, he was talking about some Linux systems and stuff like that, and he was talking about MIPI being a little bit more advanced than the low-end Linux systems he was building, but that's basically the standard for everything these days. So like raw data coming off of cameras and things like that. It seems like that's kind of the jam these days.
Yeah, go ahead, Ryan.
So we use basically 3 MIPI inputs. We have one that's a 4-lane MIPI, and then 2 2-lane MIPIs. And the SOM is basically situated so that it's directly on the output of the cameras, and it can be essentially a front end for the imagery data, which is then processed locally and sent out. You can either send out metadata or the processed imagery. So I think that's one of the main advantages, is that instead of the kind of circuitous routes that Brandon had been alluding to with other SOMs, this is positioned so that it can directly interface with the raw imagery, process it, and spit out results directly to the host. I think that's probably one of the most powerful features that the SOM offers.
So you're saying in other solutions you'd have to have some intermediary for the MIPI? Is that the idea, or like for the cameras?
Right.
Okay. So, and I guess that kind of goes back to the prototype then. You're saying that the whatever you guys were using, there was some, or I guess there's an actual Intel dev board that actually has the Myriad talking to the MIPI, but then you had to export all the frames and then process it elsewhere or something like that. Am I getting that right?
So there is a dev board, but we didn't use that on our initial prototype.
Okay.
On the initial prototype and on some other solutions out in the world, you may have camera data that comes into an application processor. The application processor then sends it to the Myriad, which crunches on it, runs it through the AI models, and then the Myriad sends it back to the application processor. So the downside to this is latency. And if you're wanting to do anything real time, particularly for edge applications, embedded applications, latency is a big factor. Particularly in the biking example, you don't want to have a lot of latency. It also needs to be small, and so putting the Myriad directly on the output of the cameras was essential for what we needed.
Yeah. Okay. All right. And can you explain the 2-lane versus 4-lane on MIPI? What does that mean?
Yeah, so it's essentially it's kind of like PCIe, where there's differential pairs that carry the data from the camera back to, in our case, the Myriad X. So for 4-lane, there's a clock generated by the camera, and then there are 4 data lanes that come back with that clock. So that's what 4-lane means. And then in the case of 2 lanes, there's just two differential pairs coming back with the clock.
Okay. All right, cool. Yeah, that's great. And so if I was going to build up one of these systems, then what does it start to look like? I'm kind of just, to be fair, I'm scrolling down the /depth AI page. So if people are following along at home, you can also be doing this. We're kind of working our way down. You can see the SOM and everything that's on there. But like, is the SOM always integrated into something else? Or is it the idea that, like, where would people start and where would they probably end up?
Right. So we offer a lot of our baseboards as open source on our GitHub, and you can find almost all of them there, I think. All the ones that we've tested and validated, of course. So the suggestion would be go there, use one of those baseboards as a template, and slap our SOM on there. And you can rebuild it to whatever application you need, any form factor you need, reuse the circuitry that's on those baseboards, and then as long as the interface to our SOM is correct, you should just be able to snap that thing on there and it'll go.
And to add to that, all of the boards are also purchasable. And then
good,
we have
good.
some.
Yep, that's good. Kicking in with the sales there. That's good.
Yeah. So it's the sales, but then also the risk factor, right? You don't necessarily want to have to build your own board to get your prototype, and that's largely what we allowed or what we sought out to allow is to solve problems that we couldn't solve because the platform wasn't out.
Yeah.
And we wished we could just buy one of these. So like we talked about how there was the version with we had to buy a Raspberry Pi and the Neural Compute Stick 2 that has the Myriad X in it and the depth camera and all that, and then kludge it all together on my wife's like shipping crate. and we wish there was just a board that had all that. And so it, like, one of the ones you can just buy actually has the full depth integrated, the Myriad X on board, and actually has a Raspberry Pi compute module on board. And so like literally that fits under a bike seat, and you just go mount it under a bike seat and do the thing. Or all these other applications that we realized, like, well, if this doesn't exist, it's probably going to be useful in a lot of other ways because it's such a cheat code for understanding the world real time on some embedded system.
Yeah, yeah. And I should back up too. I didn't mean like you're hawking your product here. I actually meant because we had talked before the show about like your Kickstarter and how you guys actually teamed up with Opencv, and because you're double E's and you're focused on the technical stuff, and actually Opencv approached you and said, hey, let's actually work together to get this out to more people, which I think is actually really great. And you raised, I mean, $1.3 million on Kickstarter. That's like pretty significant. So what was that process like?
Difficult.
Okay. All right.
So not because of OpenCV, they were great. Doing a Kickstarter, it's just something none of us had really done before. OpenCV had done one before, but around courses. So it was a learning experience. And I am, this is probably the best spoken I've ever been, serendipitously, I think, because there's not a camera on me.
It is easier, isn't it? It's like,
Yeah.
we're just, just chatting. It's like a phone call.
Yeah, it's so much easier. So I had to record, like, if you look on the Kickstarter, there's a page where I'm like describing what the platform is, and the goal was to get it in like 30 seconds, which I don't think I accomplished, but I got it like to 45 or something. And that took me probably 48 hours of work total to like record that one video.
Yeah.
So that's why I say it's like painful. It's just stuff I'm not good at. I'm getting forced to be better at it, but it was still just an onerous amount of work and weekends trying to like put that content together and pretend like we know how to market things. But yeah, I think it validated, despite all that and our attempts to make things look clean and tell a story, it validated that, yeah, this is something that the world wants. And we were able to achieve our primary goal, which was just to like, we've been kind of working in a corner, not knowing if the world would want this, or it doesn't exist. No one had built this before, so that's either because it's useless and smart people knew that you shouldn't build it, or it's we're in this wave and we're early and we're just the first ones to build some useful thing. So it told us the two things we wanted to know, which is, one, it seems useful, a lot of people backed it, and then two, okay, we actually got some engineers out in the world to know that this exists, and now it's a tool they can use to build their own solutions with.
Yeah, I feel like the risk is like electrical engineers is like, we're like, well, people will just go build it. Like, oh, I built it, I can build it, other people build it, and that's not what most people want to do. And specifically, like the software world, where they're like, no, I need the data. All I care about is I don't even care about the software. I care about the data. I care about the thing in coming out of this thing. That's all they really want. And it's like, this is a great solution. And honestly, when you think about the compact nature of it, so now we're talking about the Oak One and the Oak D, which are the two things that were two of the things that were on offer for the Kickstarter at like $150, so cheaper than MSRP, whatever. But like, it's compact, it's targeted at ROS and robotics types applications, and it's just like, it is the answer, and it seems like it's a low cost answer. It's like perfect for the Kickstarter kind of price level. So I can imagine that would be kind of right up the alley of a lot of people that need this sort of thing.
Right. Yeah. And we were trying to just price it as low as we could to just get it into as many hands as possible, which is a trick, because we're working with component vendors like cameras, for example, where a small order for those guys are maybe 1 million cameras.
100,000. Yeah.
Yeah. And so like, we're talking to them and we're like, well, we can order like 10,000. They're like, okay, well, it's going to be a super high price, right? And like, also it's going to take 18 weeks. And so it was a trick trying to get it down to a price that's like stomachable, so people can build off of it, and then to get the volume, and then get to a point where now we can put 100,000 unit camera orders in, so we can get like reasonable pricing, sort of thing. So that was the other part that was hard, right? Is you're doing your estimates, you're trying to figure out what the pricing should be, and then you realize, oh, but we should build in batches. Our pricing just got like a lot worse. And you're like, okay, when you're pushing it that tight, right? It can get scary really fast, and it did. But then it turned out that most of our calculations were about on point.
That's good.
But yeah, we tried our best to try to keep it as low as possible, and we're going to continue to do that, and hopefully we'll be able to get even more compelling pricing as we go forward and do volume orders and that sort of thing.
Yeah, of course, right. And I imagine like longer term, as a business type thing, it'd be like, this is effectively marketing for the other stuff that Luxonis is doing, right? I mean, you guys are not stopping at one camera, one board, one output, right? It's like, this is the introduction to a business, and it's servicing the community, it seems like, significantly. But it's like, this is going to be growing your business in the longer term, and you're going to keep supplying other CV type solutions in the future.
Right. And our little niche in the world. So what didn't exist was when you have a problem that requires these 5 things. So it's embedded.
Mm-hmm.
So it's like, low power, small, relatively low cost, fast boot time,
Mm-hmm.
performant. So you can like really do some complicated crunching on it real time, fast. So like solving the bike safety thing, for example. Spatial, so you can perceive in the physical world real time. So it's not just image classification, like, oh, there's a dog in that image, but it's like
Right.
there's a dog 30 feet in that direction going this trajectory, sort of thing. AI, which is what allows you to know there's a dog, and then like CV, which is like allows you to do like real time digital zoom, like lossless zoom, and feature tracking, all these other complicated CV functions. So that's what all this is about, and that will continue to be our niche. And that's what the whole Kickstarter is about as well. Is it's really those like 5 things, or maybe 4 out of those 5 things if you use it with a computer, which a lot of people will do to start. And then the goal is 6,000 backers, maybe 30 of those will then say, well, sweet, this really solves the problem. And they'll build a product, right?
Yep.
So yeah, it will continue to serve that market, and it's it's super niche right now. The Kickstarter, I'm told, broke both records for a computer vision project on Kickstarter and then also a PCB project on Kickstarter. And that was over 30 days. We raised, around $1 million. And then like the 2 days before our raise ended, a table announced on Kickstarter, which is a sweet table. It's a gaming table, but still they raised $6 million in one day.
Oh my
and it
God.
shows how much of a niche this is now. But it's just because it's, this is the only chip in the world that allows you to do this. And this is the first use of it in this platform. So I don't think it's going to be a niche for long in that, but we are going to stay in that niche, right? So it's embedded, performant, spatial, AI, and CV. And that's what we're going to continue to release products around.
Cool. Let's talk a little bit about Opencv. So Opencv, you said paired on the marketing side of things, but that Opencv is what, like a package? It's like isn't that Python based? I actually don't know a ton about it, but like it seems like there's a foundation there, but there's also, there's actually software behind it as well.
Yeah, so Opencv is absolutely humongous. It's the number one computer vision library in the world, and also for applied AI, it's number one in the world for running inference. So it whether you're doing PyTorch or TensorFlow, they have their DNN module, which allows you to execute these models more performantly, and it pairs with OpenVINO, so you can get like 10x increases across a variety of platforms.
I don't know any of these words you just said, but I think what I'm gonna bundle this in my mind is software and the box that happens in video when it says this is a dog. Is that fair?
Yeah, that's right. That's right. That's their DNN module.
Got it. Okay.
So so they've got bindings for Python. I think Julia, just like came out too. I believe I heard that yesterday, and in all these other languages, JavaScript as well, and so it's used in all sorts of applications. The stat that I most recently saw is like when you're doing some sort of like edge AI, so you're running on some small processor, not like on a full desktop and not on like some server, but some small processor somewhere like a Raspberry Pi. It's like 89% of computer vision is done with OpenCV. So it's this huge library. It started in popularity largely from the DARPA Grand Challenge. So I believe it was Gary Bradsky is part of the DARPA Grand Challenge, was building this library, and they're the ones that won, I think. And very rough on this history. It's through the grapevine to me, clearly. And then it's continued to evolve and help people solve computer vision problems. So it's kind of the go-to when you're like, okay, well, I need to do this thing to an image. You use it. So over these 20 years that OpenCV has been around, it has been largely towards computers, but computers have been getting smaller, right? Like this edge type. So like Raspberry Pi is another small, like Linux solutions, and starting to blur the line between like what is embedded or not, like embedded Linux. And so OpenCV saw this and said, well, this has been something, clearly they saw the same thing. Like this platform should have existed. There's a chip that enables exactly this platform. Why doesn't it exist? And had wanted to actually build the same thing. And so we were already open sourcing the hardware and software and AI training and everything. So they're like, well, this is a no brainer. Why don't we go on this together? And then we can take some of the proceeds to feed back into the open source community, open source vision. I'm forgetting the technical name for it, but to fund opencv.org, the nonprofit, to use that community. And there's, it's like 43,000 GitHub stars or something like that. So there's this huge community already around OpenCV, and this is something that community has wanted. So it's kind of a natural progression.
Yeah, that's great, and that does help to build the base of, like you said, you have to bootstrap your way up and to get vendor attention, to get volume pricing, or even the beginnings of volume pricing, and just show you're legit enough. And pointing at a 1.4, I misspoke earlier, $1.4 million Kickstarter, that helps. I mean, that's maybe still small potatoes for them, but like that's at least gets you at the table, and that really can help to start some conversations and show that there's a future forward, it seems like.
Yeah, absolutely. And with like 6,000 backers, even for a large company, releasing something to get 6,000 interested
Yeah.
people
Yeah.
quickly is really valuable.
Yeah, just a mailing list even is like, that's
Yeah,
like, oh, okay, that's the thing now. Yeah, that's good.
yeah.
When you say it's a library, so does that mean that it actually gets? So it's like, I thought it was like Python based, but it's actually like what, written in like C, C++, and then like compiled down for each platform. Is that how it works, or what does the actual library mean?
Yeah, so it's and I don't know the distribution actually for the Opencv library. I guess I could pull it up on GitHub real quick, but yeah, it's C, C++, and then there's compilations for all sorts of platforms, for effectively all platforms, and then it's auto
Yeah.
built
Okay.
for a variety of platforms. And the same is actually true for the library that interfaces with the Opencv AI kit with Depth AI. So it's C++ primarily, and then we have bindings for Python, and also bindings for robot operating system.
Yeah.
And then it's since it's open source, then the community can add bindings for other things, like Rust, for example. But those are the two that we maintain, or three, I guess, we
Okay.
maintain. There's a C++ API. There's four. I'm sure the number is going to keep going up. So there's C++ API, Python API, ROS, and then there's also an SPI API that's C++ based. So like if you could hook this to like a @mega 8 if you wanted with that API, like you're using @mega for something,
Right.
you could take this SOM and connect it over SPI, and then just get these, 30 times a second. You just get like a string of text that says, your dog is now at this distance, or like the ripe. Here's the text describing the locations of all the ripe strawberries in the field of view of your robot, sort of thing.
Wow. Yeah, this thing's gonna be everywhere. That's crazy. Okay, let's talk. So just to map out where I'd like the rest of the show to go. One would be the Myriad chip, and then I'd like to talk about the actual implementation, because it seems like the manufacturing challenges are significant on this. So first off, how much did you guys need to know about the Myriad chip? What is the Myriad chip, and what is your relationship with the makers of the Myriad chip, which I believe is Intel?
Yeah, so man, that's a great question, and I'll try to not be circuitous in my answer. So how much did we have to know about the Myriad chip? A lot. Part of the only reason, or like probably the only reason we have this opportunity, is when you have these new capabilities. So the Movidia's team was prescient in a ton of ways, and that's part of the reason Intel bought them. So they saw that, on a computer, you build these sophisticated pipelines of maybe it's like 20 or 30 different things. Like you're doing one type of CV function, say disparity depth, and then you're doing like edge tracking and motion estimation and feature tracking and object tracking, object detection, and then like feature extraction, and then you're tying these all together in some pipeline. And the way that works on a computer is like the CPU and the GPU, if you're using sophisticated software like Opencv, will intelligently orchestrate those. And that's one of the value adds of Opencv, is it'll let you build that pipeline and it'll run performantly on a computer. But they said, the future is this is going to be run on embedded devices. So they architected a network on a chip system where it has like 28 different types of processors in there, like literally. So like there's a processor for doing the disparity depth estimation. There's a processor for doing motion estimation. There's a processor for detecting edges in images. There's a processor for detecting lines in images. And then there's this network on chip architecture that allows you to tie those together in a performant way. So you can prioritize what gets the highest bandwidth and what gets lower bandwidth. Because say if you take your input image and you do edge detection first on it, you need the highest bandwidth connection to your edge detector, because it's a full 12 megapixel, so 12 million pixels at 30 frames a second, a lot of data. And so that network on chip allows you to build that sort of pipeline. So their vision, no pun intended, was you have these complicated pipelines that are running on these CPUs and GPUs. What if you made an embedded system that allowed you to physically build that using hardware engines, so it could be way lower power, it could be way lower latency, and give you these like full computer functions on a little chip.
So yeah, so at first I was thinking, as you were saying, 28 processors. I'm like, holy shit, the excuse me, my language. The power seems like that would be a lot, but actually that on a chip might be better. But what I think you're saying is, like with the pipeline piece, is that you're not like buffering and multiplying these images coming in at 30 frames a second times 12 megapixels. I mean, it seems like it's just a fire hose of information, and you don't
It
even
is.
have time to split it out and do anything with it. So it's just about who gets access to that stream of data first, and then
Yes.
does something with it and kind of passes it on. Is that right?
Yeah, and the streams get like less and less wide as you like move through the chip. But the trick is like maybe the thing that takes the fire hose first is feature extraction. Maybe it's a neural network. Maybe it's motion estimation, right? And so the network on chip allows you to then like have the bigger pipes first. So you can say, I want the bigger pipe going to motion estimation, or I want the bigger pipe going to neural inference. And as you build this pipeline, generally the information gets smaller and smaller. In a lot of cases, the thing you care about is where's the strawberry, which is then like 5 bytes. And so that's what the network on chip allows.
Yeah, it's XYZ maybe.
Yeah, XYZ and like the class and like ripeness percent or something, right? Like
Yeah, okay.
it could just be 1 byte if you like super cleverly encode it in some cases. And so that network on chip is incredibly powerful, but it's incredibly difficult for engineers to work with that. I mean, you have like 28 different architecture types within a single chip.
Yeah,
like learning how to
right.
write like for an AVR can be challenging, or an x86 can be challenging. Imagine having 28 of those.
Right. You're like, maybe I'll just sneak up the stack a little bit and
Yeah.
do a little bit less coding for each processor.
Yeah, and that's the huge challenge of the chip, and largely we're just enabled by the fact that we have experts on the team who are part of the original Movidius team who like helped architect the chip and like know all these things and have spent combined like decades working on this architecture, so they can like nimbly work between this and know the limitations and then provide. And so our value to the world on that is like, this thing's insanely powerful, it has the hardware to do all those things, but it's very difficult for the programmer to do anything because it's so new and there's so many architectures to learn and permutations. And so our value add is to say, okay, here are the key things that you can do with it and make this pipeline builder that then someone in like 8 lines of code can literally say, I want, let's say, feature tracking followed by neural inference, followed by disparity depth, followed by these other things, just as single lines.
How flexible is that? So is it all you get to choose which goes first, or is it like that flexible?
Yeah, and that's what's taken us a ton of time and a bunch of the effort. So we kind of had like 3 stages of like our software, which our first was like just absolutely terrible. And then the second was like, okay, we like learned kind of what people want now that they've seen the terrible thing and used it. And we made this more like rigid, which like you could run pipelines of things, but only certain orders and very rigid like structure to it. And then and we were like, that's pretty good, right? Now you can run like 4 neural networks and inference and all these other things. And then people were like, well, yeah, but for my application, I have 67 neural networks and they're tiny and I want them in this like lattice structure that I've refined over 2 years. And so we quickly realized, okay, that we're going to have to make this like fundamentally infinite permutation. So you can do whatever order, just limited by the constraints of the part. So we spent a lot of time building what we call our Gen 2 pipeline builder, which is out partially now. And so it allows you to run arbitrary series, arbitrary parallel, just limited by the resources of the chip, which usually come down to, how many hardware blocks exist. So you can do 3 parallel video encoders, for example. So like the pipeline builder will not allow you to do more than 3 parallel video encoders. And you can do any number of neural inference in any combination. And so we have examples now showing like 6 different neural inferences in this like diamond pattern. And then we have some for doing various like depth. But yes, it allows you to do any permutation that the chip would allow in this like very easy to use builder where you can write it in Python or C++, or you can do like a drag and drop GUI where it's like, here's the input camera, hit, choose the features you want. And then you can add nodes to this pipeline builder too with Opencv, which Intel made. So we leverage a lot. We're standing on the shoulders of giants here from Intel's tools. Say there's feature tracking is a capability you can do. Well, some companies have spent 2 years making an amazing feature tracker and they look at ours and laugh, right? And so they can use Opencv, which is this tool to then implement their own node of a feature tracker and then use that in the pipeline as well. So it's extensible and you can write MicroPython and put it as a node in the pipeline as well.
Wow. Yeah. So it seems like you guys are almost augmenting. It's like a new. So it seems like one of the limitations you had at the beginning is like you're using a dev board, right? That's what you guys used to start with. And that exposed some feature set. And then you're like, okay, now we're going to put this chip on our board. And then you basically make an in between dev board kind of thing for other people. That's what the SOM is acting like. And now you're like, okay, now we have to open up all these other new features. But then, of course, like any dev board, everyone's like, well, no, I need to do this custom thing.
Yep.
I would hope that means then you guys get to go, well, welcome to the project. You are now you are now a contributor. Do a pull request whenever you'd like. Like hopefully that means that the project continues to grow. But yeah, it's there's no depth to how no depth. There's no there's no limit to how much customization you can have and how many permutations you can have of like software that might target this processor and this solution. It seems like.
Right. And we actually didn't even start with a dev board. It was just a Raspberry Pi. And then it's a little neural compute stick, which looks like a thumb drive. And so
Oh, I thought that there was something with the Movidia Sonnet. Is that not right?
there isn't publicly available. There are dev boards you can get like privately through Intel,
okay.
and they work with large customers on those. And
Got
part of the reason they limit that to large customers is it is very difficult to develop on the chip.
Yeah, they need like six FAEs just to get the thing booted, kind of thing, and yeah.
Right. Yeah. I mean, it took me 2 weeks to get the first example running. Like, no joke, just full time 2 weeks, like 12 to 16-hour days to get it running.
Yep.
And I know engineers who just gave up. And the best engineer we ended up hiring, serendipitously, best for his age, I guess I should say, he got it running in like a day, and I was like, "You're a genius! Like, you're an absolute genius."
It's like the test. It's the test that you get them through.
It's the eliminator. Yeah. I mean, we've had 6 engineers just call us a bunch of clowns and quit trying to, like, because it is the test. They're like, why would you ever take on a mission like this? like I will have none of this. Thank you and goodbye.
I'm just amazed looking at this. So I'm looking at the picture of the SOM, and it looks like maybe an 8x8 millimeter chip or something like that. And just like what's in there is just, it's the same size of other chips that I use. And yet just the difference in what's in there compared to the kind of stuff that I normally work on, it is amazing the differences in silicon,
Yeah, they took a very unpopular approach, and that's why it's different. So like back in I guess in like the late 90s, the world said like, all right, we've had it with asymmetric multiprocessors. Like that's dumb. Like
right. We leave this to the FPGA folks. If you really want to do it, go buy an FPGA, damn it.
Yeah, and even then you can't really do that many different processors in there because you just run out of gates. A lot of the reason it's so different is they came from this background of like computer vision and what these pipelines and what you need to do, and then also chip architecture. And then another barrier to entry that Movidius like went past is like it's very unpopular to have these asymmetric multiple cores, because then it's the reason the world went away from that.
Tool chains.
Yeah, the tool chain, and then how much the developer has to learn. And so largely the world said, let's just do symmetric multiprocessing. You have a CPU and a GPU and maybe an NPU for neural inference. And in the efficiencies that we get out of it being easier for programmers to learn it are worth the lack of efficiencies we get in terms of like the hardware architecture. So there's a huge trade there, and there was definitely a cultural bias on the part of the whole world to not do asymmetric multiprocessors. And the Movidius team said like, nah, we're doing an asymmetric multiprocessor, and that's why it has these unique capabilities. It's like one of the few that kind of like broke the mold, if that makes sense.
Definitely, yeah, it definitely does. I mean, I don't really have any reference point here, so like, it all makes sense to me. I mean, it works, so that's cool. Yeah, no, it is interesting that Intel bought them, because it seems like that's out of the Intel way of doing things. But I'm sure Intel is also trying to, we just heard the news about Intel no longer being in, like in terms of the dominance into the future. They've been trying embedded for a long time with varied success, and it seems like this is so application specific, but it's also going to just be so big, and this is what I approach all of this computer vision type stuff. It just feels like it's so out of my realm of possibilities, and it seems like the Depth AI board actually maybe makes it accessible, which is kind of cool.
Yeah. So our goal is to make it so like a digital artist could grab this and like they want to make a sculpture like interact with someone walking by or mimic their pose or like an interactive display. Like you can just take our reference example, change like 3 lines of code, and then be like, now it tracks this. So the goal is to make it super, super accessible. And one of the products actually just boots up doing that. So you don't even have to type anything, and it's just tracking you in physical space. And for Intel purchasing it, I do think Intel is going to win in this space, actually. So this whole AI is going to be absolutely huge. Intel did see that the spatial part is what's like a whole missing market, really. So and they saw that with the Movidius team, and so these all the other solutions on the market right now are this kind of like 2 or 3 piece where you have some AI, you have some processing,
buy a GPU,
and buy a depth camera, right? And what Intel saw was like, well, actually, all this huge looming wave that's tiny now, absolutely tiny, that I mentioned on earlier, is going to have the spatial part, and that's what Movidius is all about: is having the spatial and the AI. And there's a reason we have 2 eyes, right? It's the spatial part. And so this is one of their chips. We're working with them on future versions as well, which are just going to be absolute monsters. Unknown time frame right now, but it's I think they're totally going to win this. And so Intel did see with the Movidius acquisition, like, oh, holy cow, this first off, this market is going to be huge, and Movidius is the only company that's doing this.
Yeah, at the silicon level too. I mean, like, that's what's interesting is, like, I mean, and Intel has silicon, I wouldn't say dominance, because I think that they're neck and neck with like a TSMC, but they have all this capability, and they have what looks like a shrinking, maybe flat market. And so it's like, okay, so what else? And it's like, well, yeah, this is a very legitimate play into the future, it seems like. So that's great. Let's talk about the board itself. So boards, sorry, my bad. Boards. You guys have made a couple boards here. So what is the realm of boards you have been making, and like, what are some of the issues with getting these manufactured? Because I'm guessing that buying a part from Intel is not going to have the easiest geometries.
Yeah, I can speak to this maybe a little bit. The part is a very fine pitch BGA. It's not the easiest part to work with in terms of manufacturing, but we found a good CM who knows how to put this down reliably every time.
And just for there's fine pitch and there's fine pitch. So what are we talking about here? What is the pitch of this part?
Well, it's not CSP level, but it's 0.4 millimeter ball grid.
Yeah,
and
it's tough.
And it's a full grid under there. There's several hundred balls under there, nearly 400, I believe.
Okay.
So it's fully packed. It's extremely dense there, but our CM has done an excellent job of manufacturing and getting the reliability down.
Yeah, I mean, and so you guys are racing towards, I think in Brandon's LinkedIn thing, it says delivery by December. So how we doing there, guys? You stressing? I mean, December 17, 18 days away?
We're doing real well.
Great.
We have everything going as planned. We are on track to hit all of our targets.
Are there going to be depth AI modules in people's stockings this holiday season? Is that what we're hearing?
Yeah, we're looking to get ahead of schedule if possible.
Wow.
We're hoping to get our first shipment out mid-December.
Wow, that's great.
And have the rest of our items shipped by the end of December, of course. So we're on track. We're going through the whole process now of making sure that quality is up to snuff, doing ramp builds. We'll pilot builds first, then ramp builds, getting our test process line down. Yeah, going through that whole gamut there.
Yeah. So this is the Oak D and Oak. Sorry, the names are Oak 1 and Oak D. These are the ones that are going out. Is that right?
Yep, that's correct.
Okay. And then if people are looking this on the actual Kickstarter page, one like has the kind of like it. I mean, it looks like the eyes, almost like it's like looks like a ET type character or something like that, where like the board kind of goes outside the envelope of the heatsink, but it's to get that actual XY separation.
That's right. So that's the Oak D that has stereo vision, and that provides the spatial plus AI that Brandon has been mentioning.
Yeah.
The 2 cameras that are out kind of on the arms, we call them, that provides your stereo vision. And the Oak 1 is just a single camera. So that doesn't have the depth with it, but it does allow the user to, push the image data right through the myriad and get all of the benefit from that.
Yeah. And there's no way so you can't like hook in like a MIPI ribbon cable camera into the Oak 1. It's a standalone, does its thing. Sits there generating heat with the color camera, right?
Yeah, right. I suppose you could. It would require a lot of engineering work to get the right camera and the signals and everything. Right. So it's really not made for that. We do have another model that does have FFC output
Yeah.
or input,
Mhm.
I should say. And we actually do have a little adapter board for the Raspberry Pi camera. So you can actually take just the Raspberry Pi camera, run it through our adapter board, which changes formats and voltages and stuff, and
Mhm.
pipe that directly into our FFC variant. That's not part of the AI kit, but it is available on GitHub and on our Shopify, I think.
It is,
Cool.
yeah. So, and that's another thing worth mentioning is the Kickstarter was largely to allow us to get down on price and then to just get this in a lot of folks' hands and get to like the price that ultimately should be. But we do have low quantity versions available now, including effectively the equivalent of what's on Kickstarter. So some of our backers, there's actually one of my favorite quotes is like one backer saw Kickstarter, reached out to us, or like saw our web store, bought it, used it, and then reached out to us and said, "This is the most satisfying Kickstarter I've ever backed because secretly I could actually have it with overnight shipping." But it's just like twice the cost because everything's just so much more expensive at the low volume
Yeah.
runs. But yeah, all the models
Right.
you can just buy now, including the FFC and ESP32 variants and so on.
Got it. Okay, so the Kickstarter is more like it is the volume buy. It's like it's you're bundling effectively to get the lower price.
Right.
We should say that there are some special bonuses for the Kickstarter. For example, an IMU on the Oak D, and some aluminum cases that we don't have for sale now or prior to this.
Yeah, so the Kickstarter is like an even better deal. You got like half off, and you got this like kick-ass aluminum case for both Oak One and Oak D. Whereas the ones that are twice as expensive now do not come with the IMU and do not come with the awesome enclosure.
Yeah. Here's the thing. I at the risk of disparaging Kickstarter buyers, some of them are looky loos, right? But some of them are very legit. But some of them are just like people that are like, oh my god, this is so cool, I'm going to buy this, right?
Sure.
I always wonder about like I've always wondered this about Raspberry Pis. Looking at my pile of Raspberry Pis at home that have just sat dormant, right? I'm only speaking about myself, not other people. But like, I buy it because it's cheap, and I have grand plans for it, and I'm just like, oh yeah, I'm gonna get to that next weekend, and it just never happens, and it's fine, right? And this is, at a price point where it is very cool. I mean, like it's something that people will tell themselves to do that. But within that group of 6,500, like you said, there's probably some subset of them that are like, they're ready to go right now. And some of them, obviously, the one person just called you to buy it right away. Some of these
Yeah.
people are probably robotics researchers or people that need this as a technology, and price really isn't an issue. And I imagine it's from what you've been saying so far, some of this stuff doesn't exist outside of, an NDA signed with Intel. So it's like, okay, well, that's not really a thing then for me. So it seems
Right.
like
Yeah.
this is just going to be opening up the market in the first place.
Yeah, and we're super excited about that.
I think that's one of the things that is kind of an unknown here, is that this is such a new feature set, just this entire combination of things, the spatial, the AI, the ability to configure the pipeline the way you want. We don't know how people are going to use this, but we know that people will use this.
Yeah.
So, just getting it into the hands of, even like you said, the looky-loo, so to speak, they're going to come up with things that we can't even dream of. And we're so excited about that. Yeah.
So this is like a super accessible thing, right? I work on industrial equipment, boring, like high reliability, but like never would ever have this on here. But, industrial has a higher price margin just because it's usually low volume and the people that need it, or you really need it, that kind of thing, right? So there's usually
Sure.
higher margin. You can put more tech into it if you need it, but it's never needed. So usually the company takes the margin. Okay, fine. But I can imagine, a box sitting somewhere in like a very high importance place and just being like, okay, I need to detect when a operator walks up to the box. I could pop one of these things on there, and versus, anything that I would design in there, I could actually tell when someone's about to walk up and utilize a box that I might have designed the other stuff there. The thing that's on there might have like, a PIC processor, something stupid simple, and all I have to do is flip a pin high, or the PIC has to get an interrupt or whatever, and it's just like, I could actually do that sort of thing now versus before. What was I going to do? Maybe a tripwire? I don't know.
Right.
So
we've had customers that have applications like that, detecting a person doing a thing, and detecting a person doing that thing somewhere in space. That's all possible with this product.
And your point about a pick is a really good one. So like there's all this IoT capability out there, like temperature, humidity, salinity, pressure, vibration. And so you have this IoT capability to then garner information, say an industrial application of like, well, what is the state of all of these things? They're maybe deployed all over the world, right? And you can monitor them remotely with this like quantized, presumably business value data, but that's been limited to like direct measurement. With something like this, now you can do exactly what you're talking about, where it's like, well, I want to know the person just walked into this red zone of these machines, and was he wearing his hard hat, his safety glasses, his like poisonous gas monitor, and I can now do that and not even have a like an internet connection. I can just have it over LoRaWAN. Because you can encode all those states. Like a person is there in which items they have, you have 255 possible encodings in a single byte. And so you can literally just make that your output. And so you can deploy these things.
Bitpack the crap out of it, right? And then you're like, oh yeah, it's a value 37. That means the guy wasn't wearing his hat, or something like that. Yeah.
Yep. Including with like a pretty decent amount of like CRC room and stuff, because maybe there's like 20 states you want to look at and you have 255 possible in a byte. And so that enables these cases where like computer vision was just totally intractable before, because computer vision meant you had to stream to AWS or you had to stream the video for someone to look at it. And now you just get the answer of, is there a leak, right? Is there some poisonous gas being leaked? And that's like the byte with the CRC, it gets sent out over LoRaWAN to some dashboard. And so now you can have millions of these things deployed with, only like kilobytes of data going a second sort of thing.
Yeah, that is really killer. Yeah. Well, I mean, not to eat away at your margin in audio, but how low do you think this could go? I mean, like right now, the Kickstarter boards are $100. I mean, or do you have like a future target kind of thing? I mean, like, what do you think that adding this capability could cost someday if it gets high enough volume?
Ideally, all this stuff isn't commoditized, right? So like right now it's novel, but in 5 years it's going to be in every product in the world. And we of course will be at that point some tiny portion of it, but hopefully we get to look back and say like, yeah, we actually helped a little. So I think it's going to get really inexpensive. The same way you look at just general purpose chips, right? Like this is going to become the new like general purpose chip, and then eventually this sort of pipelining and capability is just going to be in your ST microcontroller sort of thing. So we're just kind of pushing the boundaries of that right now, and maybe that'll be like 5 years when you can get that sort of capability. And short term, and so that's when the cost goes way down, right? Because these architectures are understood better and you can implement in silicon better and all that sort of thing. But shorter term, a lot of what drives our costs are the camera modules. And so RGCam reached out similar to Opencv and was like, yeah, this is what we wanted to build too. We're excited you built it, and we'd love to work with you. What do you need? And so he said, camera modules. We need camera modules that aren't so expensive. And maybe more importantly than that, but probably equally important, we need camera modules that allow, this engineer who's working in subsea intelligence for like leaks on oil lines, he needs 150-degree horizontal field of view, and otherwise the same thing. And then this engineer needs to see cyan only. And then this engineer needs this field of view, and all these different permutations that RGCam is already good at. And so they're making a M12 mount version. They're making like a wide field of view versions that help with this self-orienting of robots while they're doing all this spatial AI stuff. They're making all these permutations, lower cost versions of the 12 megapixel camera. And so that's in the short term, let's say early 2021, maybe January 2021 or first quarter probably, we'll be able to release lower cost versions of the platform that give these degrees of freedom as well. So you can have looking at the color space you want, looking at infrared, looking at thermal, and then also having the field of views you want. And then just camera modules that aren't as ridiculously performant. So like it's like the Cadillac, if you will, to use that phrase, is what we're using right now in these global shutter cameras with amazing optics, 12 megapixel color camera at 60 frames a second. In a lot of cases, that's can be ridiculously overkill. And there are even 12 megapixel cameras that are, let's say close to an order of magnitude less expensive, that just don't have as impressive specs and optics and so forth. So that's where a lot of the price reduction comes from. And then also folks can source stuff without us. The only thing they need to source is the module from us. That's the thing we sell. Mm-hmm. And so they can, choose if they want to find cameras that are firmware compatible, they can go find those and get their price down as well, whether buying through RGCam, which we'd recommend, or somewhere else if they find them on the internet.
Okay. Yeah, that's great. It's interesting that that's the limiting piece. I would have expected that cameras were kind of everywhere just because of the smartphone ecosystem, but maybe it's so vertical because the smartphone folks use them, and why would the makers go outside of it? I guess I'm not sure why it's like that.
It's really opaque and fragmented. RGCam is helping with that a lot, and others are as well. So it's back I guess a long time ago, like Bill Gates level story where he had to go dumpster diving to get information to like write initial code,
Yeah.
where he literally just like stole the source code out of a dumpster. It's kind of like that for camera modules right now, and it's a little perplexing. They use MIPI, but they have all these like proprietary interfaces to control the camera and do settings, and the drivers usually are hidden somewhere in some vaults, and so it's just really difficult to navigate space because it's so opaque.
I've always wondered why the Raspberry Pi like has an official camera, but that kind of is popping out right now too. It seems like they've sourced one, maybe even a couple, but
That's exactly why.
Yeah,
it's very difficult to align everything: hardware, the interfaces, the drivers, the optics. You have to align everything pretty much before you can start.
and the business prospect, right? Because you'll find like
Sure,
the perfect one, and they're like, well, I mean, this has happened to us, right? Like one of the camera vendors we talked to, we used the IMX 378 because we had drivers for it. And the first one we talked to, they were like, yeah, it's only $230 for the camera module. And I was like, well, that's a little high. And then Brian replied, like, that's in this cell phone. I can buy that cell phone on eBay for $80.
Right, and rip it apart, and then they say, go ahead, right?
Yeah, and then they said, well, don't worry, if you're ordering in the thousands, the price will be under 200. And so like that's the experience, right? And obviously, like we sold a thing on Kickstarter that has an IMX 378 in it and all of the other stuff and an enclosure for $79. So obviously we eventually got lower than that, but there's this business value proposition where like they just don't care. Like
right,
because they're
right.
used to cell phones, right? Like I don't know how many iPhones sold this quarter, what, like 20 million or something, right?
Many millions, yeah.
And then Samsung phones and others actually sell at higher volumes, and that's what these camera module manufacturers, those are the contracts they want.
Right. I think that's the other thing too, is that they literally tool up for those scenarios and those, maybe even those specific cameras, and then they're like, well, we don't make extras. Why would we make extras? We make enough for the like they're trying to make margin too. So like I get it from a lot of perspectives.
Yep.
But at the same time, you're trying to like get actual like on the market cameras. It just seems like there's not much of a market yet, but it seems like there's going to be, and
Yes.
this is the beginning of that time.
Yeah, and there's a supply and demand aspect too. So right now it's particularly painful. Like even before COVID in like 2019, there was an article that was talking about Sony is the furthest behind they've ever been on making image sensors, and so like they can't even make the supply that's necessary for the existing demand. And so you're saying
manufacturing wise, you're not saying like research wise, you're saying the actual like
manufacturing,
silicon.
Just straight up manufacturing.
Okay.
Yeah. And then that was in December 2019. And then, not long after that, the logistics of the world.
Everyone bought new cameras for their home setup.
Yes. And the logistics and supply chains got totally messed up too. Apart. And so it was like an even worse market for us to come in saying like, hey, we'd like to buy 10,000. They're like, we can't deliver our 1 million unit. Like, please leave us alone.
Back of the line, please. Thank you very much.
Exactly.
Wow. Okay, so can you make some predictions on what else this might go on to? Because what I'm thinking, maybe this is a stupid question, but like I'm thinking about, I was just reading an article this morning about how the ridiculousness of audio right now and how like, Spotify's buying all these podcasts and, Spotify, call me if you want to buy the amp hour, that's fine. But
get that Joe Rogan money.
Yeah. Get that Joe Rogan money. Yeah. Like there's so much interest in it right now, and there's a lot of interest in the audio side of things, obviously because a lot of people are at home, whatever. But I imagine that this is going to be making its way into consumer products and things like that. And it's the next wave is maybe not a smart speaker, but it's a smart whatever, and it's got vision in it like this.
Yep.
What does that look like in your opinions? I mean, is that like a smart fridge that has a camera?
To say what it's like we're not going to help in, but it's already in a ton of stuff, is like the iPhone. Like Apple architected their own version of this, and it's actually frankly more performant. It's the best in the world. Their cameras are incredible, also best in the world, and it does all the things I'm talking about. So if you in your application, if you can just use an iPhone, use that. Or if you can use Android, Android did largely the same thing and are neck and neck with Apple. Apple's slightly ahead.
And you're saying this is like the detection of things and for like autofocus and other type of applications. Is that what you mean?
And in physical space. So Apple actually put a LiDAR for doing depth measurement in their latest phone.
Yeah. Yep.
Which has disadvantages. It doesn't do as well outside as disparity depth. So we have an advantage there. But there are these solutions that exist. So our niche is in this embedded. Like if you're actually making your own product where you can't just put an iPhone in it. And good examples of those, what we've seen so far, probably the one that's the coolest to me is visual assistance for the visually impaired or the outright blind.
Oh, yeah.
So the thing perceives what things are and where they are in physical space. It can do semantic segmentation, which is like handing a 4-year-old a crayon and saying like, color all the cars blue. And you can do like depth-based semantic segmentation. So all the edges of the car in physical space and edges of the sidewalk, edges of the road, edges of a crosswalk, where stop signs are, where traffic lights are. So all of these things. And the visual assistance that's one of these things they talk about when innovation happens. Teams around the world are working on it in parallel. And that's when it's going to happen. And there are so many teams working on this. We did a competition around this spatial AI. It was sponsored by Intel, the Opencv spatial AI competition. And we got like 325 entrants for that. And over 60 of them were actually for visual assistance. And we got some really cool stuff out of it.
And just to give an idea for what that is, that's like, what's that Daredevil kind of thing? Like, but basically like actually making people that are visually impaired, like actually giving them like another sense, right? That's kind of the idea.
Yeah, and there's all sorts of ways to provide that feedback. Like one of the most intuitive is like, you can put it in different modes based on control from your fingers or speaking to it. And like you're walking through a park, it tells you that's what you're doing. And you're like, hey, tell me where the nearest park bench is that is empty. And then it'll be like, it'll find it and tell you in physical space and guide you to it.
It'll give you like directions.
Yeah, and that's like the most intuitive way. It can give you directions and keep you on the path and let you know when you're meandering off the path or if there's a car about to hit you. Very similar to the bike thing. And that happens to visually impaired a lot. And not just folks who have outright blindness, but visually impaired where you have lost one side or something like that. It hurts with social distancing during COVID, for example. So it's like a device you'd wear. I mean, it's like we're talking about like Star Trek stuff. It's like Geordi's visor, right?
Yeah.
And you can even like see thermal and like, no, you shouldn't touch hot things, right? So it's in that direction. And you can provide feedback that's like tactile. Some are actually doing research that's straight neural feedback as well. And so it gets very sci-fi very fast. But that was really cool to me because it's going to improve a lot of people's quality of life.
Yeah.
And then there's all sorts of autonomy in like aerial and subsea drone applications where you're making some like embedded autonomous thing. E-scooters are an interesting one. So we've seen a lot there, which is safety for the scooter rider, but actually more so safety for the pedestrian from the scooter rider, from the e-scooter rider, which is like this can
scooter like accessibility scooters. You're saying not like Bird and
no Bird
scooters.
And
those
Lime
guys.
Those guys. So people ride them like a bunch of jerks. But if you imagine, and so that's a bane for pedestrians walking by, and you get buzzed. People ride them at like 20 miles per hour around a blind corner. So with this spatial perception, you can just make the motor turn off.
That's right. Throw them into the street. Come on, man.
Well, it'll
let's say maybe we could have a deceleration. I guess fine. We'll have a slight curve. But come on. They deserve it. You can
make it and you can measure that too. So if they're coming towards someone at a bad trajectory, you can find them. You can turn the motor off, so they have to manually push the thing now. If they're riding in an area like on a sidewalk, the thing can know you're on a sidewalk and it can slow it down. So there's really I didn't think of that. Like people reached out to us because they were trying to solve that problem in that market, and I think that's going to be huge. Like I think in the next 5 years, every e-scooter is going to have something like this. So like you can't be a jerk riding an e-scooter effectively.
They'll find a way. They will find a way.
You'll have to be innovative. There will be the innovator.
It'll be
of
harder.
Being a jerk. Yeah, exactly. Yeah. So then there's like cargo and transport and autonomy. There's all sorts of like cargo optimization you can do automatically, and like it's like where humans would have to go inspect things, and now you don't. Or in cases where this can be embedded, so it's like human-like perception. And there's a lot of problem spaces where if you came up with a solution, you're like, well, if we could just cram a human into a 1-inch by 2-inch thing, it would totally solve this problem. And now you can. So that's in like transport and cargo stuff. Sports monitoring. So A good example there using the pipeline builder is 12 megapixel camera on Oak 1. So 12 megapixels, pretty high resolution. It can actually run at 60 frames a second. When you film with an iPhone, unless you're like a really diligent dad, like filming sports, you're not using the zoom feature. And so you look at the footage and it's awful because, they're on the other side of a soccer field. And you could zoom, but usually you don't, and you're too lazy. And
Come on, people,
shaky.
get a DSLR, get some lens, get some glass on there. Let's
yeah. And so you can get the glass on there, and you can have a thing that intelligently motion-based or AI-based or tracking the ball-based, or an AI model that's trained on like what are cool scenes in sports, because now you can do that. Can automatically, either with a telephoto lens, physically zoom in, or do for like filming like youth sports, where you just want some action, and like 720p video is great. If you had a cropped, just punched in 720p video, so you can 12x lossless zoom on the platform based on that like AI metric and get great action of the scene. And the most basic way is to do motion.
You can follow. You're saying you could follow the soccer ball like all the kids are following the soccer ball?
yeah, exactly. And you just follow along. There's a hilarious one, by the way. So these products do exist, but largely they use like cloud processing now, because it's only now that you can do it on device. So you can do it a lot cheaper and without having like a huge 30 megabit per second cell connection for the game sort of thing. But one of them, actually, there was a bald referee. And so it was trained to follow the ball, but they had never done any training footage with a bald referee. And so it kept zooming back to the guy's bald head and would just watch him for like 70% of the game. It was quite hilarious. Smart agriculture is another big one. So like you can put a bunch of these embedded things on there and get an exact metric of like the trough that you dug, like metric on the trough. And then also, where did you put the seeds? How often do you put the seeds? How are they oriented? Safety systems, like are you leaking oil out of something on some remote site?
You're saying now that we can watch the grass grow, we can watch the paint dry with cameras? Is that
and quantify it? And you can quantify it.
That's right.
You can get all the data you want on your drying paint.
That's right. Is it dryet.com? No.
Yeah. I would love that website. Please make it someone listening. Yeah. So then safety systems. So like in Colorado alone, there are 500,000 remote sites. So like quite far from a city that have hazardous chemicals, because when you're from oil and gas, so you can make solutions now. Like, and the way it's solved is people just drive there to check, like, is it leaking awful things into the environment? Checklist, yes or no. And this can perceive that, right? And then be connected over LoRa. So even if you don't LoRaWAN, even if you don't have connectivity, it can give you that business intelligence, which then is hugely beneficial to the environment because you catch a leak a lot earlier.
Like methane leak, like that one methane like gas thing that was leaking for like a couple months. They didn't know about it, but it was like one of the biggest polluters in Ohio or California or something like that, right?
Yeah, I vaguely saw that actually. Yeah. And then security, like this is a very US problem. Most of the international audience won't fully get this, but like detecting guns in public spaces, like in schools, for example, and knowing where they are. So like when there's an active shooter situation, it's unfortunate that there's a market for this, but when there's an active shooter situation, you can give intelligence as to where the hell is the shooter, right? Like in what room of like a 400 room college campus or a 4,000 room college campus is he actually? And you can do it low bandwidth and just having a model run on device. And so that's one of the key things I think I failed to ever really mention here is you could do privacy-centric detection of things. Like if you want to know if someone's carrying a gun, you can literally design the hardware so an image can never leave the device. And it's only metadata out, right? So you can have like a gun detector, and that's all it does. It says, yes, there's a gun, or no, there's not a gun. And if there's a gun, where is it in physical space? And then satellite applications.
Does that mean we're going to be seeing privacy-centric, this camera is not a camera that has an internet connection in the bathroom or something like
that? People have proposed that, actually.
Yeah, I believe it. Then it becomes just a public trust issue. I think it's beyond the realm of technology. But at that point.
Yep. And in those applications, so folks have actually reached out and proposed that. And I thought I was like getting trolled, and I almost replied to an email with like, I'm not sure if I'm being trolled right now. But then I was like, all right, be cool, reply with some legit questions. And so one of the common solutions actually is then to use some other domain of sensing with this same computer vision. So like thermal, for example, for cases where you want to monitor what a person is doing, but have no physical way to know what that person looks like or anything.
For putting frosted glass in front of the camera, you could still see thermal. There's something akin to that, right?
Yeah. And so that's one of the common. And then in satellites, this is going to be huge, especially like Earth observing satellites for like Google Maps, for example. If you're taking pictures of clouds all day long and then downloading all of it and then realizing, great, that's a bunch of clouds. I wanted to see the streets is a huge waste, literally of, hundreds of thousands of dollars and like bandwidth and other operational costs and energy and so forth. And so having, that capability, and this is starting to get more towards AI, just AI in general and non-spatial. The satellite one's just more like embedded AI. Yeah. But that is one of the applications. The first like 8 I listed are involving like the spatial component. So that's where we like are very helpful.
And this sounds, so we've talked about like at various times on the podcast, we've heard or talked about or have been advertised on edge. Like whenever someone says edge, this is the kind of thing where I think about it. It's like you're basically saving a ton of bandwidth, right? By pushing the model out to that thing. In this case, it is like an edge device because it's like the model is living on. So we're detecting a gun, to use that example again. You're not shipping every frame for 30 frames a second up over a cellular connection or a satellite connection or a Wi-Fi connection. You're just watching for that gun on the device. And then once you do, it's just ticking a bit high. That's all it is, right?
Right.
Yeah.
Yeah. And so we're kind of in this. So edge is like the craze in AI right now, which is like, to put it succinctly, what is edge in these views? So it comes from engineers who work with, computers that are the size of like a skyscraper in Manhattan, right? And so edge to them is like an Intel NUC, so like a Core i9 in a relatively small box. And that's what like edge computing is. So it's like in your grocery store under a checkout stand. And so we're like, embedded is barely a thing yet for AI. So there are companies pushing the boundary on that. Opencv is one of them. TensorFlow Lite supports, let's say, Opencv, and in others in that direction that allow you to bring AI into pure embedded. And Opencv is a great example. And then where we fit, Kwabena, who runs Opencv, is a friend of ours actually. Where we fit is, Opencv is embedded AI and CV that's easy to use, and you can go put it into something. And our differentiation is, there's only so much you can do on a STM. Ours adds this kind of like more layers of networks, more layers of computer vision, and this pipelining, and then also the spatial aspect in embedded. But it's kind of this new frontier, and almost everything you hear right now is actually about like this edge, which means like a small computer put somewhere rather than actually like embedded, integrated into a product.
Yep. Awesome. Well, you guys are building more computers and more things for the edge, but you're looking for some help. So who are you guys looking for to help build out the team?
Yeah, that is a great question. So, and Brian, you should talk more to this, I think, after I go. But so Brian is our hardware engineer and the guy who does everything. I also used to hardware engineer. I did like 2 of the simplest boards with Brian's assistance. So we need an Altium board designer who loves just making stuff super fast and it works on first turn. So that's probably the number one need from this is someone who sees this and says like, yeah, I see your Altium designs and like, yeah, I could definitely do that. Do these other permutations. Yeah, just crank out boards. Like someone who loves cranking out boards and making it look easy. That's who we want. We're up against a tall order here. A lot of our competitors have 100 or 1,000 times our number of employees. So we're pretty unreasonable people with pretty unreasonable expectations. Filter on ourselves.
Well, he did already mention 6 people walking out of like, you guys aren't, so it's going to be high stress maybe, but high reward, it seems like too.
Yeah, high reward.
And you get to make some cool ass things, it seems like.
Yeah, you can have them if we succeed, and anyone we would hire would need to be helping us succeed in material ways. We could have a real impact on the engineering efficiency of the world. Something that's pretty hard to do. And it's just because there's this huge wave right now, and we happen to be kind of towards the front of it. And so that could potentially catapult us. But yeah, we ask anyone who's interested in applying to self-evaluate, because we're in such a crazy workaholic, high stress state that it takes someone who's super high self-motivation to just go like high raw talent, like a lot of capability to just execute, and then someone who can just sprint. So it's like those 3 things: self-motivation, talent, and capability to sprint, because there's just always so much stuff to do. It's always so much,
and it's going to be remote too. I mean, you guys are both based in Colorado, but it's probably remote, it seems like.
Yes. Yep. We are a super remote culture, which is kind of enabled by that. Hiring that type of person enables being remote. Otherwise, everything falls apart, as kind of like COVID is making the world realize with remote work right now.
Yep. Yep.
So yeah, remote can work anywhere in the world. No expectation that you need to move anywhere. We have people in Taiwan and Romania, Slovenia, Poland, Colorado, California, New York. So we're already everywhere. so
Yep.
so yeah, anywhere's fine.
Yeah, I mean, I think you pretty much nailed everything on the head. Yeah, someone with Altium experience would be kind of the chief demand there. All of our boards are in Altium, and then all the qualitative stuff that you mentioned is paramount as well. Not sure I can add anything else there.
I mean, and it's just the board stuff you're looking for right now. I saw other stuff on the job site, but maybe that's not as relevant to this crowd.
Our most pressing is the board stuff. Yeah, probably for this crowd. Brian, what were you going to say?
Yeah, I was just going to echo that. We do have other options available, and yeah, see the website for that. But for this crowd, for the hardware engineering side, anything on the full stack of building the board, schematic, designing, layout, test process, anything in that realm, I'm doing all of it right now.
Okay. So basically, you're trying, people that are here, listen to Brian's pain and try and reduce it. That's what we're trying to get towards.
Yeah, that come help.
Yeah, we have so many exciting permutations of things that could be made, and a lot of the gating, blocker here is firmware often, and we've kind of gotten over that hurdle. So for a long time in the company, we had all these boards that Brian had done a fantastic job making, and we were just like, well, cool, you can't do that much with them. And then we finally got to the opposite situation. You couldn't do that much with them because of firmware. And then we got to the opposite situation where now the firmware has all these capabilities, and there's all these permutations of boards where the firmware would just work and already supports, like putting a Pi Compute Module 4 on there, doing triple camera PoE. We already have the whole PoE design qualified and working on an evaluation board, but then making that into the final product and working with the mechanical engineer to build it. Oh, that's another one. If there's a mechanical engineer in the audience who can build things for mass production quickly and has that experience, doing injection molding, like all our stuff is injection molded, and doing all the tolerances and working with the CMs and having a good feel for industrial design. We're in the process of hopefully hiring someone now that we're trying to bring on who'd done contract work for us, but there's going to be more room for that. So that's a lot of what so the mechanical engineer who has industrial design experience and really good experience doing injection molding and die cast stuff. I meant to say die cast earlier. And then the electrical engineer who's just like full stack, right? Who can go from idea all the way down to like producing the board and helping with test equipment and maybe even writing some code.
And full stack on the mechanical side too, with a strong sense of how to do integration with an electrical product. I think that's going to be real important too. Whoever that ends up being, I'll probably be working with closely, bouncing ideas off and rapidly iterating on board shapes, design, test point locations, the whole issue there between mechanical and electrical. So anyone who can do that full stack mechanical would be fantastic.
Awesome. And as an amp hour thing, don't forget to send in your portfolio or your designs that look like these designs. Show your work, folks. That's important.
That's huge. We would love that. Yeah. But yeah, and then there's the final pitch, and for those that are interested, I mean, there's thermal. One of the guys who works here made the open thermal camera, so we already have drivers and experience with thermal cameras, and literally the gating item to making a thermal equivalent of this, which is pretty much Predator, the movie, is literally just a board design, right? Like do the whole board design. We already have the firmware support. So there's all sorts of like really interesting permutations that we can move on, including with all the RGCAM modules for making these permutations. So I think it would be exciting and really satisfying work. And there's a lot of customers that are, just waiting, like, okay, looking at their watch, like wondering, when this next revision is going to be out and this next feature set, and in terms of hardware is going to be out.
Yeah. What about the so the 100-pin interface that's on the SOM? How do people find information about that? If they're like, well, I don't want to maybe design, I don't want to go join these guys yet. I don't think I'm there, but I'd like to actually integrate this thing. Where do they go find information about the SOM, but also other stuff to get started quickly?
So I actually just finished putting some information together and uploading that to our GitHub. So you can find that information for our SOMs on our GitHub, along with pinout information and data sheets. I am still in the process of fully kind of filling that out. Still have a little bit of work to do there, but that's where I would direct people. You can also find footprints and schematic symbols for Altium.
Okay. And I'm sure KiCad symbols are on the way, folks. Don't worry.
Yeah, we can do that as well.
So that's the cost of admission for being on the Ampere, I guess. Altium's fine, but come on, let's get a KiCad footprint here, guys. Come on, let's go.
All right.
We can do that.
Request received.
All right, great. Just add it to the pile.
Yeah, whoever joins can help on that one. So you need Altium and KiCad experience. And then what Brian was saying about finishing is formalizing the data sheets, but all the information is there. So there's a nice table for the pinout, and then of course there's the Altium schematic library and PCB library, and then all the reference designs as well that then show you how to use it.
Yeah, and the SOM you can buy today. Is that right?
Yeah, so there are three variants of the SOM you can buy now. One is intended if you have a USB host, some Linux processor. The other is intended if you're using like an AVR or a PIC, like you mentioned, or an ESP32. Mm-hmm. So it has integrated NOR flash, so it self boots instead of booting off of a Linux host. And then there's a third that has 16 gigabytes of eMMC on board, a bigger NOR flash, and has PCIe host support. And that is actually intended for power over Ethernet gigabit application. So for robotic applications, a lot of times the physical nature of the robots, they do not want anything to do with USB. And PoE is super convenient, field serviceable, still high bandwidth. I've used it as connection to a dog collar before because it's that robust. when I couldn't find the leash. We have that module as well that then allows power over Ethernet interface instead of USB or SPI.
Okay, yeah, that's great. Okay, so we should talk about this other thing. I proposed this idea of like, well, what if people want to build? Well, we were talking about like the high variety of things that are out there. So like you guys are seeing so many applications already, right?
Right.
So one of the things that we were talking about is like that it'd be possible to do volume discounts or something like that if people are publishing public designs will result in a couple different things, possibly. What are you guys thinking?
Yeah, so you brought up such a good subject, which is like there are so many permutations of like different industries that this go into, and like how do we service them? Obviously, we're trying to make these like designs that people can lower barrier of entry, but to a certain degree, when you're prototyping something, it would be nice if like a design already existed. Like we talked about the thermal camera version, and like we could electrical engineer and a mechanical engineer could team up and make an open source reference design. So like how to scale that, you had a great idea offline, which was, is there some reward that you could do if people open source that? And there were kind of like two potential rewards. One is getting discounts on the hardware, like our system on module or optics or cameras. And we would definitely be up for that. So if someone takes our open source designs, makes something useful, they show that it works, we were stoked to give you like a special discount for having done that and open sourced it and adding value. And we could even provide a list of those things, but maybe even more importantly for folks who kind of run their own like consulting services and board designs and stuff.
I mean, this is me being selfish. I'm like, oh wow, I bet there's a lot of. This sounds like there's opportunity here, guys.
Yeah.
Sounds like someone needs some consulting help.
super useful for us too, because I mean that's one of the main things we talked about. So many permutations, and we're not able to do it yet.
Yeah, you're getting like I can imagine like so many people are reaching out and just saying like, I need help with this thing. I know that I have this problem, and it's always that marketplace of like, there's a problem, there's people that can offer a solution, but how the hell do they find out about one another? It's like there's networking, blah 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 blah, but it doesn't always work out like that. So if there are solutions in the marketplace though that are open source, that is a great, this is like people join the consulting forum and they're like, maybe younger consultants are like, how do I get work? I'm like, well, if you publish some designs, usually that's a great way to get your name out and like show that you can interface to this thing that is a new capability effectively.
Right. And this is a whole new huge wave. So that could be even more valuable than say just getting discounts as you publish this design, show that you know how to make things and it has this, new capability. Thermal is a good example of their power over Ethernet with 3 cameras. And then you can become the go-to person as part of this wave for doing these implementations, whether it's commercial fishing or e-scooters or what have you. And we are like you expected, getting a ton of reach out of like, well, can you make this custom board for us? And then we it's incumbent on us to go find and tell them, well, we're going to go find a board layout house that can do this for you, and see if they have room in their schedule. But if having this community would be super valuable. So if someone posts up on GitHub, we'll say, yeah, like we'll always refer work to you, and this can be this like funnel, because clearly they'll trust that you know how to do it. You've already built a board, showed that it works, added this value.
Yeah. And I actually had someone asking me that the other day too, about like consulting, like, well, why would they come to someone like you versus like just going to a design shop too? And it's like you mentioned, like the scheduling might be a thing, or it might not be a big enough opportunity, whatever, but it's really about that targeted knowledge and that targeted connection as well, which is kind of interesting. I mean, for better or worse, right? I mean, like it might not always work out, but it does seem like that could be a good way for people that are, looking to get into consulting to do this sort of thing. So it is kind of a leap of faith, because people might need to go and build a board for their own use, detect when their dog's in the room, or whatever the actual use case is. And that's interesting in its own right, but then it might be, potential work down the line.
Absolutely. And even if we, totally fail, because that's one of the risks, right? Is like, well, we built this board for these guys that think they're going to do something cool, and then, we fail at our mission. Having experience doing computer vision based board design is that's just going to be like such a hot thing to have, right? That like someone like a manager somewhere is trying to solve a problem. They're like, oh, that guy's done a board that's computer vision based and didn't screw it up. So all these unknowns that, I as the manager don't know about in computer vision, obviously he didn't screw him up. So let's hire that guy. He has experience in it. So even if you do this, and then you might end up getting work that has nothing to do with our platform, which is totally fine with us, but it would be great experience to have, to kind of like de-risk yourself in that industry in the eyes of someone who would be paying you to do the work.
Yeah, and you mentioned like an interesting example as well. I don't know if you wanted to mention that here too.
The phishing one?
Yeah.
There's I read this book that's called How Innovation Works, and it fits really well with this example. So in commercial fishing, they've wanted to have intelligence on like what fish are down there to prevent bycatch, which is catching like a porpoise or a turtle when you're trying to catch some fish that people are going to eat, or catching some other illegal species. And so what happens is you catch all those things you don't know you have, and then the regulations, at least in the US, you have to throw the whole catch back if you have too many of an illegal species. And so it's hundreds of thousands of dollars worth of fish. And they've wanted to use computer vision, and the computer vision algorithms are actually already capable of doing what they need. Counting the number of fish, detecting the species of fish. All the AI models can already do this.
Fish, turtle.
Yeah, exactly. Fish of this species, fishes of this species, turtle, and then providing that information. But just like this How Innovation Works book, and they talk about the invention of sliced bread, the thing that actually prevented the invention of sliced bread, which everyone uses the best invention since sliced bread, right? People had made machines that automatically slice bread, and everyone just hated them and never caught on, because it just meant that you would steal bread all the time. And so the invention that actually made sliced bread awesome was a machine that would slice it and put it in packaging at the same time. So you could have sliced bread that was still not just like rock hard, terrible, dried out bread, stale bread. And it's the same thing in commercial fishing. And I'm convinced that there are a million industries that are like this. I knew nothing about commercial fishing. Many companies reached out to us about this. Is the cabling, when it comes to applying computer vision to commercial fishing, is a problem. You're wanting the cameras to be 2 kilometers away from you, typically. And how do you deal with a 2 kilometer cable if you're getting a video feedback? And the thing's hundreds of feet underwater. You can't just use RF. It gets absorbed in like 2 feet of water. And so how do you deal with that? And this embedded spatial AI fits that problem perfectly, because you can do all the processing, the detection of species, the size with the spatial aspect, and then you can compress that down into just a couple bytes, right? Which is like, what are the distribution of species? And it can be compressed down so far that you can have the data actually sent back over just sound waves in the water, like dolphins talk, right? And that goes kilometers really easily. And it's such low bandwidth that you can have hundreds or thousands or tens of thousands of these frequency division multiplexed, or more complicated if you want, in just the audio spectrum. Think like a 56K modem for those that are old enough to understand what that is. So just sound waves, and that solves the problem. So just like, sliced bread, no one wanted it until there was packaging in the machine, and it was a bread slicer and a packager all in one. This is, these commercial fishermen have wanted this intelligence but couldn't do it because of just the cables. The CV tech has existed, but the cable prevents it. So copper cable corroding or getting crimped. You do fiber optic, great, then it doesn't corrode, but you can't field repair it. And also you end up, like you mentioned offline, end up with kilometers of cable storing on a vessel. It's a huge logistical problem, and you want to use that space on the vessel for fish, right? So that's like a canonical example, I think, of industries where computer vision tech just couldn't be used, and now you can, because it has this totally different way of information flowing. You have this like 1,000,000,000 compression effectively on device, where it's this high bandwidth 10 gigabit per second video feeds that are coming in, and then your output is just counts of fish, the size and species sort of thing.
Right. And this is what made me think about the consulting thing, because it's like, when the hell would I ever hear about that? Like,
right. Yeah.
I don't know any fishermen. I live in the middle of a country. I'm landlocked, effectively. I mean, don't count the Great Lakes, but like, you just
Right.
wouldn't. I would never hear about that. And yet,
Yep.
a commercial fisherman or someone in that industry looks at something like the Depth AI, and they're like, oh, there's the answer, and I need help with that. But then they come to Brandon and Brian. They're like, hey, can you guys build this? And they're a little busy. So
yeah. So out there, if you're listening to this, you know how to make, do electrical engineering. You take this. We already have a system on module with ESP32. You could literally write or make a board that transduces that through water. Like, you could have a proof of concept, and I think people would buy it from you.
That's pretty crazy. Well, this hits all of the things that I care about. Consulting and technology, and it's businessy too. So that's super cool. This is great, guys. All right, cool. Well, people can go to luxonis.com, luxonis.com, and then it's called Depth AI. And also, you can go. How do they apply to this job? Is it just click the button, or there's Brandon's email?
Yeah, it's pretty much just straight to my email, so it'll be going to me. And like you mentioned, it would be fantastic to have some point out to whether it's KiCad or Altium or portfolio to show the boards you've made, or as a mechanical engineer, the products you've made.
All right, guys. Well, thanks for joining, and I'm really excited about this stuff. I'm sure we're going to hear from you again, and I'm really excited to. Well, maybe I can actually put one of these in my products. We'll see how that goes. That'll be interesting.
Happy to help, and super appreciate you hosting us. This has been really fun.
Yeah, thanks a lot, Chris.
Yeah, thanks for being here. Embedded computers may be gaining depth perception and object recognition, but they'll never match the depth of generosity of our patrons. Join the club at patreon.com/theamphour, and you'll recognize discounts to Amp Hour objects. A special thanks today to our corporate sponsor, Binho, who now offer the PC Byte.